Welcome, everyone. I'm Paul Lefevre, the Xojo Developer Evangelist, and our topic this time is threading. So what exactly is threading? Well, it's a way to let you run your code outside of the user interface thread. And the user interface thread is, where your user interface code is all running. So if you write code that's in a button or something like that, that's running in the user interface thread. And that's how most of your code is often going to run. But sometimes you may have code that takes a long time to run, and you want to keep the user interface responsive. So you don't want it to lock up so that, it says application not responding. You get that little spinning wheel on the Mac. The user won't be able to interact with anything. So you don't want your app to do that. So that's when threads can come in handy. And there's a thread class in Xojo that lets you do this. And on iOS, it's in the Xojo.threading.thread class. Concepts are the same. I'll be showing desktop stuff today, though. And to use a thread, you just add a thread subclass to your project, or you can add it to a layout. Sometimes it's easier to add it to a layout if your needs are pretty simple. And then you put the code on the run event that you want to actually run in the thread. And anything that you call from the run event, so if you call methods or anything like that, that also runs within the thread. And then you actually call the run method on the thread to start the thread up, which initiates the code, initiates the run event calling the code that's in there. And that's how you set up a thread. So a little bit more details about threading. The threads are cooperative. So this means they are much simpler to use than other types of threading, which is often referred to as preemptive threading. Cooperative threading, you don't have to think about a whole lot, and you can just code up your stuff like I described earlier, and it'll kind of just work. The downside of cooperative threads is that they all are going to share the same CPU core. So you're not going to be able to spin out a bunch of threads and run them across all the CPUs that you have in your system. Priority, you can set priority for your threads so that threads can have more time to run than other threads or even the main user interface thread. We'll look at that again in a moment. You can suspend or resume your threads. So if they don't need to be running, you can stop them. Then you can start them up again at a later time. But probably the most important thing to remember with threads is that they cannot communicate with the user interface directly. So a thread itself cannot modify a user interface control or any of its properties or methods. And if you do so, you get an exception, you get the thread accessing UI exception, and then that's the end of your app. So you can't do this. All right, so what are some questions that often come up with regards to threading? Well, people will often ask, well, why do I have to use threads? Why can't I just use a timer? And a timer can be neat. That'll run some code, periodically when whatever you set the period for the timer, that action event will be called and your code will run. But the important thing to remember about a timer is that it also uses the main UI thread. So, if you have something in a timer that is processing intensive, it's still going to affect your UI. So that's probably not what you want. Another question that's commonly asked is, will threading speed up my app? Well, yes and no. Generally speaking, the code that you move from the main UI thread into a regular thread is going to run slower because it's now sharing time with another thread. We'll look at how that works in a moment. So that isn't going to actually run faster. If you've got a process that normally takes 30 seconds to run and the UI is totally locked up and you get the app not responding thing, if you move that to a thread, it's going to take longer than 30 seconds to run. However, for the user's perspective, it's entirely possible they'll think your app runs a lot better and faster because you can kick off the thread and they can keep doing something in the user interface. They don't have to wait necessarily. How can multiple threads share a resource? We'll look at an example in a moment for how multiple threads can write to a file, for example. Normally, you wouldn't want two different threads attempting to write to a file at the same time. That could be bad. They could step on each other. So there are ways to manage that using something called semaphores. And I mentioned before that threads cannot access the user interface. So how do you cope with that? And we'll look at some examples, techniques that you can do that. You can kind of do the reverse. So rather than the thread talking to the UI is going to talk to the thread. And I mentioned the Xojo threading is cooperative. And the question is, how can I take advantage of multiple CPUs and cores? Well, I did another webinar that showed some techniques on this. I believe it was called a console webinar. I'll put links in the show notes. But essentially, in the case of Xojo, you can make helper console apps that your main app can call, and it can kick those off, often using a shell, passing the information it needs to do. And those will be scheduled by the operating system itself, typically to run on another CPU or CPU core. So that's how you can do that with Xojo. So let's talk a moment here about priority. I mentioned that's how you can control the amount of time available to your thread. So you can think of priority as setting time slices that your thread has available to it. By default, all threads have a priority of 5. And that includes the main UI thread, which always exists. You're not going to get rid of that. So there's always a main UI thread that has a priority of 5. So looking at an example, consider that you have your own thread. We'll call it T1, and it also has a priority of 5. Well, the way Xojo figures out how much time to allocate to these sort of things is it takes the two threads that are running, so your user interface thread and your T1 thread, and adds them together, adds the priorities together to come up with how many time slices are available. And that would be 10, because both of these are 5. And then it goes back and it calculates the percentage of time based on your priority. In this case, both of these have the same, so it will come out the same. So the T1 priority divided by the time slices is 5 divided by 10, or 50% of the available time that the app has. And then the same thing with the user interface. You get another 50% of the time. So that's the default. If you don't change anything, you add a thread, it'll run and get approximately 50% of the available time in the app. But if you want to give your thread a little bit more time to run, you can give it a higher priority. So consider that you give your thread a priority of 20. Now there are two threads again, the user interface thread and your thread. User interface thread is 5. That's its default priority. So we now have 25 time slices to work with. And we still do the same division here to calculate the percentage. So the thread priority of 20 divided by 25 equals 80% of the app's time will be allocated to the thread. And then the user interface priority is 5, divide that by 25, and that is 20% of the user interface time. So now your thread is going to get more time to do its thing, and the user interface less time. And this can be a good technique if you're not really doing much in the user interface at that point, and you really do want your thread to have more processing time. You can tweak it a little bit here. The user interface still is responsive. User will be able to use menus and click on things or whatnot. But your thread will get done a little quicker. Sharing resources with semaphores. Semaphores is a computer science-y term that just means some sort of object that tracks access to shared resources. And in the case of Xojo, there's a semaphore class. And it has a signal method that you can call to get a lock. And when you get your lock, that means you have access to the resource so you can use it. And if you call signal and the resource is already in use by another thread, then it's just going to wait. It'll cause your thread to wait until the other thread releases its lock, and it is available to you. And this technique just prevents resource from being accessed concurrently. By default, a semaphore just monitors a resource for one thing. More complicated uses, you can say, oh, this particular resource can be used by 5 things at once. But typically, it's just one. There's another method on the semaphore class called try_signal that will check if there is a lock available without forcing your thread to wait. And depending on what you're doing, this might be a technique you want to use. But if you're in a thread, the signal, just calling signal and letting the thread wait often works just fine. And the important thing is when you're done accessing the resource that you call release on the semaphore so that that frees up your lock and allows it to be available to another thread. We'll look at an example of how that works in a moment. And last, well, I'm not going to be sure this is last, but next is updating a user interface from a thread. So as I said before, you cannot update the user interface from a thread, but you can do the reverse. So the user interface gets information from the thread instead. And there are 2 options or techniques available that people use for this. The first one is that you put a timer on your app. And as I mentioned, code in the timer runs in the UI thread. And the timer periodically, when it runs, asks the other thread, your thread, for information. And that thread can be setting properties or something that the timer can read. And then once the timer has access to that, it can use it to display it in the user interface. Also included with Xojo in an example project is something called the task option. And this is a subclass of thread. And it has an update UI event and corresponding method. And this class is implemented so that you can put code in the update UI event, and that code will be able to talk to the user interface. And essentially, it has stuff behind the scenes that allows that update UI code to run in the UI thread. But this is kind of all in one, so you don't need a separate timer. And the way this works is in your thread, you implement the update UI event. And then somewhere in the run event of the thread, you call the update UI method to have it eventually trigger the code in the update UI event. And that code will be running asynchronously, so you're not going to have it necessarily be step by step. You'll just tell it, all right, now you can go ahead and call the code to update the UI, and then it will do that, but the thread's going to keep running. And the update UI event does have an ability to pass in parameters in a dictionary, which means you can pretty much just populate a dictionary with whatever you need and send it along and then use it there. So let's now switch over and look at some demos of some of these concepts. All right, so first I have here a simple project. And it just has some code here on the start button that runs a loop. And it calls a generic method here that just is purposely slow. It doesn't actually do anything. It's just slow. So if I run this right now, there's no thread or anything here. And I click the button. You see the UI is locked up now. I can't click anything. I get the spinning wheel of death, as they call it here. If I click on the icon, it says application not responding. All the stuff that makes your app not look great from a user standpoint. And then here, and you can see, everything was locked up. Even the progress bar was not getting updated while that app was running. And it just updated to the end when the code finished. So that's less than ideal. So how would we go about converting that to use a thread? Well, the easiest way to do it in this case here is to actually add a thread. So you grab it here from the library. Icon actually looks like a spool of thread. And then here I just put it, drag on the layout so it showed up on the shelf. And if I go to the event handler, there'll be a run event that I can add. And typically what you want to do is you want to have your long running code in the thread's run event instead of where you had it before. Now I had it here before, so I can just grab it. And there's no point in grabbing this here because this is setting the progress bar to 0 because the process is starting. And remember, we can't touch the user interface in a thread, so I'll just leave that code there. And I'll put this here. And this is now the long running code. You notice it's calling a method. The method's on the window, but that's fine. It's not part of the window user interface in any way. And because it's called from the thread, that method will be run as part of the thread. And then back here on the start button, I can actually call the thread. That now runs the code on the thread. And this would actually do that, but our code actually doesn't do much except update a counter that the progress bar is intending to show. So the next step would be, well, how can we get the progress bar to update that value? And that would be to use the timer technique. So you can go back to the window here and we can add a timer. And we'll start it as off. And then on the timer event, I can tell it to update the progress bar using the value that the thread updates, which is this property progress value. See there. And I can tell the timer to essentially disable itself once it reaches the end, so it doesn't keep firing for no reason and not really needing to do anything. Now, if I run this now, expect we're going to get an error because I left a little code bug in there intentionally. And so if I click start, we get a runtime error here, and it's on this line of code. And look, that line of code is in the thread, but it's trying to modify the progress bar directly, so it raised an exception, the thread accessing UI exception that I mentioned earlier. So this is a no-no. This code can't be using that code there. So we just need to remove it since we have our timer handling that anyway. So that is not needed. Now I'll run it again with that code out of the way. And of course, when I do stuff live, they never work right. But the start button started it, run the thread. Oh, I didn't turn on my timer. So I started the thread, but I forgot to turn on my timer. So let's do that. I remembered to turn it off when it was done, but I never started it in the first place. So let's try that again. And now the timer is running periodically. I think I set it at 300 milliseconds. And you can tweak that depending on what your needs are for the user interface. But you can see the thread is just running in the background doing its thing, and the timer periodically says, hey, thread, give me your status so I can toss it up here on the user interface. So that's how you can migrate something to run in a thread. And what the code is that's running in the thread here doesn't really matter. pretty much any code you want can run in the thread, as long as you're not touching that user interface. All right, I want to open this project up here. This is just to, just going to run this so you can see just the different effect on priority for multiple threads that are running. So you can see here, this is running 4 different threads, and they have different priorities, and some of them are very high numbers. But you see, even though those are given a lot of priority over the user interface thread, I can still use the user interface. But the other thing to note is the ones that have a higher priority, these are all a little bit similar, but this one here has the highest priority. You can see it's counting, more rapidly because it's getting more time slices. And the one with the fewer time slices available to it has the lowest count. So it's just getting less time to be able to increment its counter. Again, this isn't doing anything except incrementing a counter. And I can suspend one, and then it'll stop running. So you can see that's just how priority affects the time available to the thread. Our little example we were looking at before, that we converted the non-threaded code to be threaded code, we used a timer. And this is an example that essentially does the same thing, but it uses the task class. And you can see here, same sort of thing, just a simple window with a progress bar on it. And it has this task class added to it, and you can see that's just dragged in from here. And if I expand that, you can see there's the update UI method that has some code in here. And the run event, looks very similar, except that it is calling the update UI event and then passing in some stuff. This is using a pair, but a dictionary is also an option, so it's passing in a value, or just an identifier, really, and then the value we want, which is the counter. And then this will periodically be called and be able to talk to the user interface, which in this case is the UI progress bar. So, it pretty much works the same as the timer, giving you a way to update your user interface. And like I said, it's a little more self-contained than using a separate timer that you have to coordinate with the thread. This is kind of just an all-in-one solution, so it works well for that. All right, and the last example here is the Semaphore example. And what this example does is it's going to have a file on disk, and it is going to have multiple threads write to the file. But they're going to be controlled using the semaphore. And so if you look at the thread here that does the writing to the file, once it's started, this particular thread will just keep running forever and write out to the file. And doesn't really write anything to the file except its thread identifier or thread counter and the date. But you can see it calls a signal to see that it can get a lock on the file, and then it calls a release after it's written to the file so that another thread can get access to it. And in this case, I initialized the semaphore on the app. So I have a semaphore as a property here, and I just initialize it here. And I'm initializing it with a parameter of 1, which is the default, to just tell it I only want one thread at a time to be able to write to this resource, which is a disk file. Then I can start adding some threads. Nothing specific to see just yet until we quit, and then the text file will open. Well, theoretically, it's supposed to open. Well, let's see if it's on the desktop. All right, so here is our text file with threads, and you can see they were, they're running in order initially because I created the threads, but they start to run in different orders over time, depending on when the locks were given and whatnot. But, you get your file, you get lots of threads with writing to it, and nothing bad happened. And that's generally what you want when you're using semaphores to share resources. All right, well, speaking of resources, let me point you to some resources that can help you get the most out of Xojo. First of all, always head over to the download page periodically and make sure you grab the latest version of Xojo. We release, every 3 months-ish, quarterly-ish. So the new versions are often available. So head over there to check them out, download them, read the release notes. I want to encourage you to subscribe to the Xojo YouTube channel, youtube.com/GoXojo. You'll get notified when new videos and webinars are posted there. So you don't have to go back and check. You'll just get a little email that says, hey, there's a new video available. There's lots and lots of content on the YouTube channel, hundreds of videos. So definitely worth subscribing. If you're new to Xojo, be sure to check out our free Introduction to Programming book, xojo.com/learn. And also check out our user community at forum.xojo.com. And you can always learn more about these topics at the Xojo Dev Center, developer.xojo.com. And in particular, the user guide has a couple topics on threading and a topic on multiprocessing, which is the technique of using helper console apps to run on separate CPU cores. And as always, if you have questions on this or anything else Xojo related, or even baseball related, I'm open-minded. You can reach me via email, paul@xojo.com, and on Twitter, @Lefevre or @Xojo. I want to thank everyone for attending today's threading topic. Have a great day.